Welcome to this learning module on Florida stormwater and permitting. Throughout this course, we will explore the surface water impacts of stormwater runoff, drawing from over 50 years of information and research. We'll also examine the intricate web of rules and regulations at both local and state levels that guide our efforts to achieve essential nutrient performance standards. Today, we'll explore the critical issue of nutrient enrichment in our surface waters, a problem clearly indicated by various water quality measurements. These assessments have highlighted the urgent need for robust management strategies. This need led to the creation of both local and state-level stormwater programs, which we'll examine in detail. We'll learn about the specific assessments and regulations that organize the specification of annual discharge limitations, all designed to assist in improving water quality. These programs are fully supported by foundational research, such as the 2007 Harper and Baker publication on the evaluation of stormwater design criteria. All these efforts, combining local and state programs, research, and professional practice, culminated in the recent publication of the 2024 FDEP Applicants Handbook Volume 1 on June 28, 2024, which went into full implementation on December 28, 2025. Our understanding of nutrient levels in water bodies comes from extensive data collection and evaluation. Historically, back in the 1970s and 80s, significant efforts were made to measure nutrient loadings in surface waters, correlating these levels with surface runoff volumes. What these studies revealed was quite striking. In one particular study area in Florida, over 90% of the surface waters showed a clear enrichment of nutrients. This condition of excessive nutrient enrichment is formally identified as a eutrophic or nutrient excess state. The scientific findings were further bolstered by a strong social need to address the consequences of this enrichment, such as the frequent algal blooms and the unacceptable odors that often accompanied them. This combination of scientific assessment and public demand provided the necessary support to initiate efforts aimed at improving water quality through nutrient reduction. It's important to note that these nutrient measurements are typically conducted on an annual basis. This frequency is due to the long holding times of water in many of our lakes and estuaries, meaning that the impact of nutrient inputs plays out over an extended period. Consequently, the performance of stormwater best management practices, or BMPs, is also evaluated based on these annual nutrient loadings. When assessing the quality of our surface waters, we often use the Trophic State Index, or TSI, which classifies them based on their biological activity. This index is typically calculated using three key indicators: light penetration, measured by a Secchi disk, the concentration of total phosphorus, or TP, and the amount of chlorophyll, often abbreviated as CH. Based on these measurements, waters are categorized into one of three main classifications. First, we have oligotrophic waters, which have a TSI ranging from 0 to 40. These are considered to have good water quality, characterized by low biological productivity. Next are mesotrophic waters, with a TSI between 40 and 60, indicating fair water quality. Finally, we have eutrophic to hypereutrophic waters, with a TSI from 60 to 100. These are designated as having poor water quality due to their high biological activity. Measurements of biological activity in many surface waters revealed consistently high TSI values, often greater than 60, indicating poor water quality. This data, collected up until 2006, highlighted a pressing need to manage the nutrients that drive this elevated biological activity, which subsequently led to a re-evaluation of state regulations aimed at improving water quality in these bodies. In 2022, the Florida Department of Environmental Protection, or FDEP, published an integrated water quality assessment for the state, continuing their ongoing evaluation of water quality. This comprehensive report offers a detailed overview of the status and overall condition of Florida's surface water and groundwater quality. From their analysis of collected data, FDEP determined that nutrients are one of the main impacts on both groundwater and surface water throughout Florida. The assessment involved evaluating 4,187 water body segments, and unfortunately, 2,148 of these were found to be impaired. Of those impaired segments, 1,137 required the development of a total maximum daily load, or TMDL. The most frequently identified causes of impairment were nutrients, bacteria, and dissolved oxygen, with nutrients being particularly prevalent in Florida's surface waters. Therefore, it's critical that we manage nutrients from stormwater runoff to improve water quality. To address this, Florida has the Environmental Resources Permit, or ERP program, at the state level. This program is designed to help reduce the nutrients that cause impairment by establishing performance standards, requiring a specified percentage of treatment, and aiming for a net improvement where post-development conditions are equivalent to or better than pre-development conditions. Building on the understanding of phosphorus water quality data and its relationship to annual runoff, an annual basis was developed for evaluating both runoff volume and nutrient loading. This foundational knowledge then led to the creation of local stormwater programs aimed at reducing nutrients. For example, Orange County, Florida, was an early adopter, developing a comprehensive code in the early 1970s to manage stormwater. This code was initially based on treating the first inch of runoff water, primarily utilizing infiltration through what later became known as retention basins. Their specific goal was to achieve an 80% reduction in stormwater volume from new developments. The technical support for these methods was published in 1978 and became a crucial resource for professionals working in stormwater management and water quality improvement. Today, many other municipalities across Florida have followed suit, implementing their own building codes and comprehensive plans to guide development using various best management practices for effective water quality control related to stormwater management, all supported by continually evolving technical guidance. Across Florida, there's significant interest at both the local and state levels concerning stormwater management, with many municipalities having established and active stormwater programs. These local programs typically include detailed building codes, comprehensive plans, and specific regulations designed to protect water quality. Effectively managing nutrients is a key component in meeting these local program requirements and state guidelines. To support these efforts, numerous organizations specialize in stormwater management throughout the state. These include groups like the Florida Stormwater Association, the Stormwater Academy at UCF, the various water management districts, industry vendors, and many academic programs offered by colleges and universities. These resources provide valuable guidance and expertise. You can also find additional information and resources at sites like BMPFast.com and floridadep.gov/water/stormwater. Building on the success of local programs and driven by significant social pressure due to frequent algal blooms and unpleasant odors, along with robust research support, Florida adopted statewide stormwater regulations in 1981. This made Chapter 62-25 the first comprehensive stormwater discharge rule in the United States, becoming effective in February of 1982. This was a technology-based rule that established a performance standard for a minimum level of treatment, specifically aiming to reduce the average annual post-development stormwater pollutant loading of total suspended solids, or TSS. The goal was an 80% reduction for most waters, increasing to a 95% reduction for stormwater discharges directly into what are designated as outstanding Florida waters. These reduction percentages were intentionally set to be similar to those required for solids and biochemical oxygen demand removal in sewage treatment. The rule also included design criteria to achieve these levels of treatment, introduced a rebuttable presumption that discharges from a stormwater system would not cause harm to water resources, and mandated periodic review and updating of best management practices based on ongoing research. This foundational rule, which marked a significant step in stormwater management, was eventually repealed in 2017. Following increased successes in water management and the growing need for stronger direction and enforcement from local governments and conservation groups, the Florida Department of Environmental Protection, or FDEP, and the water management districts were tasked with implementing comprehensive surface water management programs. This led to the development of Chapter 62 to 40, known as the Florida Water Resource Implementation Rule. Within this rule, Section 62 to 40.431 specifically outlines the Stormwater Management Program, which became effective on May 7, 2005. Subsection 3A clarifies that FDEP is responsible for coordinating this statewide program. This involves establishing the overarching goals, objectives, and guidance that will inform how the water management districts and local governments develop and implement their own stormwater management initiatives. Then, subsection 3B designates the water management districts as the chief administrators of the state's stormwater management program. However, it also includes a provision that if a district lacks the necessary economic and technical resources to implement a comprehensive surface water management program, the department will step in to carry out the state's program in that specific district. Continuing with Chapter 62 to 40 of the Florida Administrative Code, we'll now look at Section 62 to 40.432, which deals with surface water management regulation, a section updated in 2005. This rule outlines specific design and performance criteria that the department and the districts must specify when adopting rules for new stormwater management systems. The core of this section establishes two critical performance standards. First, new stormwater management systems must achieve at least an 80% reduction of the average annual load of pollutants. This is aimed at preventing pollutants that would cause or contribute to violations of general state water quality standards. Secondly, for areas designated as outstanding Florida waters, the requirement is even more stringent. These systems must achieve at least a 95% reduction of the average annual load of pollutants. This higher standard reflects the critical importance of protecting these exceptionally valuable and sensitive water bodies from any degradation. Both of these reduction goals are central to the rule's aim of improving and maintaining Florida's water quality. While the Florida Department of Environmental Protection, or FDEP, provides overarching guidance for water treatment systems, it's actually the individual water management districts that are tasked with developing the specific design criteria for stormwater best management practices within their regions. This means that design standards and performance efficiencies can vary widely throughout the state, as each district has its own unique set of requirements. Historically, there was a rebuttable presumption that discharges from these designed systems would inherently comply with state water quality standards. However, extensive research, notably conducted by Environmental Research and Design, or ERD, and various state universities within the Stormwater Management Academy, began to reveal a critical issue. Many of these current designs were in fact not achieving the required reductions to meet those very water quality standards. This research involved significant testing and monitoring to evaluate actual performance. In 2006, the Florida Department of Environmental Protection, or FDEP, initiated a contract with ERD to comprehensively evaluate the existing stormwater design criteria throughout Florida. This work was formally performed as part of FDEP Agreement S0108, specifically titled Evaluation of Current Stormwater Design Criteria within the State of Florida. The primary goal of this extensive scope of work was twofold. First, it sought to determine whether our current stormwater design criteria were effectively meeting the performance standards outlined in Chapter 62 to 40.432 of the Florida Administrative Code, which deals with surface water management regulation. Secondly, if these design criteria were found to be insufficient or failed to meet Chapter 62 to 40, the ERD was tasked with recommending specific changes to ensure they would then meet these crucial performance requirements. Beyond this, the evaluation also assessed whether the design criteria were adequate to achieve the critical objective of no net increase in post-development pollutant loadings. For the purpose of this analysis, the focus was specifically on nitrogen and phosphorus. The reasoning here is that if performance criteria can be effectively met for these two significant nutrients, it's generally understood that they will also be met for other important pollutants, such as biochemical oxygen demand, total suspended solids, and various heavy metals. Ultimately, the ERD research concluded that the existing designs were, in fact, not achieving the required pollutant reductions. This was attributed to several key factors: the significant variability of rainfall patterns across the state, and the calculation methods themselves, which often failed to adequately incorporate the necessary watershed characteristics to accurately assess the volume of runoff. Furthermore, the research highlighted a clear need for more robust data regarding the discharge concentrations of these crucial nutrients. Continuing our discussion on the scope of work, a primary goal was to develop design methodologies that are both scientifically defensible and easily reproducible, ensuring they are practical and familiar to design engineers. It's important to note what this particular work did not include. At the time of this research, our focus was specifically on frequently used best management practices, such as retention basins and detention ponds. Therefore, this work did not extend to the evaluation of certain alternative or emerging stormwater management techniques. These excluded areas encompassed concepts like low-impact design, stormwater reuse, street sweeping programs, pervious pavement installations, and gross pollutant separators. Additionally, the evaluation of wetland loadings was outside the scope of this specific research effort. These omissions highlight the focused nature of the study on established methodologies prevalent at that time. Continuing our discussion on published results, a significant report was provided in June 2007, detailing the evaluation of stormwater designs for water quality management from the early 2000s. This comprehensive report included a series of tables, figures, methods of calculation, and design examples. These examples were specifically aimed at achieving both 80% and 95% removal efficiencies, and also analyzed pre- versus post-loadings. The methodology presented in this report was rigorously vetted by various districts and interested parties through a series of public workshops. Following this thorough review, the districts formally adopted the report as a standard method for calculating load reductions, particularly for use in pre- versus post-analyses. Critically, this foundational work continues to be highly relevant today, forming the basis for the loading calculations and removal efficiencies that are used in the new statewide stormwater rule, and are still widely applied by most regulatory programs at both local and state levels in Florida. Our evaluation of statewide stormwater rule efforts first began in 2010 with the establishment of a Technical Advisory Committee, or TAC. This committee held 8 meetings and ultimately developed a draft applicant's handbook, which was largely based on a 2007 report. To aid in applying the results of this report and other research, Excel-based software was also developed, intended to assist professionals in making timely assessments. This draft handbook was actually considered by many professionals to be one of the best ways to assess stormwater management programs that use best management practices, or BMPs, to attain the removal of nutrients required by law. However, despite these efforts, both the rule development and the associated state-funded research were unfortunately stopped for about 10 years. Then, in 2020, a significant development occurred with the approval of the Clean Waterways Act during the legislative session, which was signed by the governor on June 30th of that year. This act was pivotal, as it directly instructed the Florida Department of Environmental Protection, FDEP, to initiate new rulemaking by January 1, 2021. The directives included updating the Environmental Resource Permit Applicant's Handbook to incorporate the most recent scientific information available, considering and addressing low-impact BMPs, and establishing clear measures for the consistent application of the Net Improvement Performance Standard. Moving on to the 2020 statewide stormwater rule efforts, a significant review of design and professional practice was undertaken between 2020 and 2021. This involved numerous rule development workshops conducted by the Technical Advisory Committee, or TAC. They held 13 meetings from December 2020 through November 2021, where discussions centered on topics like BMP efficiencies, maintenance requirements, and the desired level of treatment for stormwater. The FDEP subsequently issued a final report in March 2022, which included key recommendations for rule revisions. A major outcome of this effort was the comprehensive revision of the applicant's handbook, updating the version from 2010. Ultimately, on June 28, 2024, the applicant's handbook, Volume 1, was officially published, marking a crucial update to Florida's stormwater rules and design criteria. Looking at the implementation timeline for these stormwater rule efforts, you'll note that applications for individual and general permits, which are deemed complete after December 28, 2025, will be required to meet the revised stormwater quality nutrient permitting requirements. This date, December 28, 2025, marks the full implementation of all information contained within the applicant's handbook Volume 1. Beyond implementation, the rule also establishes new maintenance requirements. This includes the need for routine maintenance cost estimates, a certification of financial capability, and the establishment of consistent inspection requirements for the permittee. These inspections will be tailored based on the specific design of the stormwater treatment system itself. Finally, the rule introduces significant flexibility. Permittees will have the option to use existing or apply for new site or regional specific event mean concentrations, known as EMCs. They can also choose from a range of innovative best management practices and utilize off-site compensation to help meet treatment performance standards. It's important to remember that these criteria will apply specifically at the project outfall. Let's now compare the previous stormwater performance standards with the updated 2024 standards. There have been significant changes in the revised criteria, providing much more definition for performance standards and offering a broader range of options for best management practices, or BMPs. Naturally, these updates mean that our calculation methods and the software we use for assessments must also adapt to reflect these new regulations and practices. A key tool designed to address these changes and to help complete assessments in a timely manner is the BMPFast software. It's developed to not only comply with the current revisions, but also to remain flexible in incorporating future research results as they become available. Our new performance standards are directly tied to your project's location within a specific hydrologic unit code, or HUC-12 boundary. The HUC-12 is a 12-digit code that helps us designate the conditions of receiving waters. It's crucial for identifying whether the water bodies downstream from your project are classified as impaired waters or designated as outstanding Florida waters, often referred to as OFWs. Essentially, you would locate your project on a map and determine if it falls within a HUC-12 boundary that includes these impaired waters, or OFWs. This determination is critical because it dictates which performance standard you must select. There are 7 specific performance standards that apply in these situations, along with 3 other options that may be relevant if your project is covered by other permit programs at the local or state level. The ERP Applicant's Handbook Volume 1, published by the Florida Department of Environmental Protection on June 28, 2024, is a foundational document that sets the standards for stormwater management and water quality control. This Volume 1 was developed by FDEP itself and applies consistently across all 5 of Florida's water management districts. Its content is largely based on a 2007 report and will be referenced many times throughout these learning modules. Crucially, Part 2 of this handbook, particularly Sections 8 and 9, contains the basic evaluation and design criteria that are essential for assessing plans for water quality improvement. We will frequently refer to these criteria to understand how fundamental science and engineering principles are applied. The handbook also allows for what's known as compensating treatment, which includes strategies like overtreatment or off-site treatment to meet regulatory requirements. In addition to FDEP's Volume 1, each individual water management district has developed its own Volume 2. These district-specific handbooks are designed to address the unique aspects of each WMD, such as their specific hydrology and distinct land use patterns, ensuring that local conditions are appropriately considered. Throughout this discussion, we've explored the fundamental science and engineering behind managing stormwater runoff, specifically focusing on its impact on water quality. We learned about the critical relationship between stormwater and the nutrient enrichment of surface waters, which has driven the need for effective solutions. This understanding led to the development of local comprehensive plans, codes, and state rules and regulations. We traced how these frameworks evolved over the years, continually adapting to new research findings and advancements in professional practice. A significant outcome of this evolution is the introduction of the 2024 criteria for performance, which brought about important upgrades to water quality plans. These updated criteria are formally published in the FDEP Applicant's Handbook, Volume 1. We also took time to compare some of the previous criteria with these current 2024 standards, highlighting the key changes and improvements. This presentation on Florida stormwater history and permitting was brought to you by Harvey H. Harper and Marty Wanyalista. As we've seen, stormwater management for water quality protection in Florida requires a thorough understanding of regulations and practice. To support this, computational tools and software programs are increasingly important. BMPFast is one such software that can greatly assist in assessing water quality, ensuring consistency with regulations, and providing timely results. We encourage you to view other related learning modules to further expand your knowledge on these vital topics. Thank you for joining us for this presentation.